Thanks for coming tonight and coming to hear about us. So I guess I thought I'd start by talking about kind of climate change as an issue and the role of software and software businesses in helping to address climate change. I was having some fun chats with people in the pre-drinks and was reminded, particularly by my colleague Phil, of a previous startup. So maybe I don't have a slide, so I'll tell you the story. So about, I don't know, 10, 15 years ago, Phil and I and some others were part of a founding team that built a business called Green Sense. Our tagline at the time was kind of making sense of climate change, and so we were kind of an energy data analytics business. So we would kind of collect data off IoT devices and on kind of energy use, water use within buildings, and we would kind of do these dashboards and displays. And I think I felt like at the time that we kind of had headwinds. So the era was kind of Kevin 07 had come about. We were about to have a carbon pollution reduction scheme. Lots of corporates were interested in carbon. You know, climate change was this kind of existential issue, this great moral dilemma of our age, and we built a business with that in mind, and it kind of went away. The politics of kind of carbon and climate change in Australia went south. And something we were still very passionate about as a team, but we had to kind of pivot our focus, or that's a kind of a startup term, pivot, to focusing on kind of energy, because energy was kind of where there was kind of commercial value and commercial savings for people who were interested in energy and energy management. And then kind of fast forward a few years and we kind of sold that business to a publicly listed electricity retailer in Australia that's now kind of Shell Energy. And then still my co-founder Pete, who's not here today, I guess he and I were still kind of very passionate about the energy space, very passionate about climate change. And energy is a really exciting area. It's kind of on the front page of the paper all the time. And so we thought we'd do another go around. And we've still got this kind of strong focus on climate change as part of the reason behind the business. And I guess when we think about responding to climate change, one of the ways that I think about it is, I'll see if I've got a slide for this bit, is that it's really about replacing infrastructure. So if you think about, we've had about a century or so of kind of building the modern energy system, which is all backed by fossil fuels, so it's all kind of oil and gas and coal. And what we've got to do between kind of now and 2050 is we've got to replace trillions of dollars worth of infrastructure linked to fossil fuel supply chains. So move your power station down in McCullagh. Fantastic news, the government's announced we're going to close that by 2030 or so. But around the world, we've got to close trillions and trillions of dollars worth of infrastructure. ATCO's gas network locally, the Karratha gas plant, all of this stuff has to go away and it has to get replaced by something. And so when we think about climate tech as a category, there's kind of two kinds of businesses you see in climate tech. So one category is these kind of hard tech, new science, new engineering businesses. They're doing direct air capture or synthetic meat or new power generation technology. And then you kind of have the software teams. And what we're doing, the software people are building enabling tech. We're building tech that's going to enable that transition. And that's kind of the role of Gridcognition. So I'm standing in front of your slides. I'll come over here behind the pedestal. So what we're trying to do is kind of help direct this investment in the trillions of dollars worth of new power and transport infrastructure that's got to replace all of this stuff that's linked to fossil fuel supply chains. And one of the things that's really interesting about energy is when we think about the energy system today, about 20% of energy is kind of end-use energy, so lighting and what have you, is electricity. So it's power stations running and generating electricity, transporting that electricity over transmission distribution lines. It's only about 20%. But over the next kind of couple of decades, it's going to become 80%. So where's that coming from? So it's kind of heating and transport. So actually there's a lot more energy that's used in heating and transport than is used in the power sector. But we're seeing these sectors become coupled together. So I'm getting my first electric vehicle soon, touch wood, I'm getting a Model Y. That's part of this kind of sector coupling where transport gets coupled to the power sector and where we replace liquid fuels, as a way of shipping and using energy. And so as the energy system becomes, the power system as it becomes electrified, our power grids become much more important, they become much more complicated, and I guess in particular for us as a business, they become much more decentralised. So the old way we think about the power system is we had a power station down in Collie, this long transmission line, this distribution network, poles and wires through our suburbs. We'd be these kind of passive consumers of energy. But in parallel with this drive for decarbonisation, we're also getting this kind of new technology to support decentralisation, which are these inverter-based energy systems, so kind of rooftop solar, EV chargers, battery storage systems. And so part of our thesis is the balance of the power system is going to shift from being predominantly kind of large centralised machines with spinning turbines to largely decentralised machines with kind of power electronics. But these projects become are really kind of complicated to model. So if you think about the old world, if you're an infrastructure investor and you want to build a gas-fired power station or a coal-fired power station, then what you would do is you take some view on the future price of energy. You would say, well, we think we can sell energy for this many dollars per megawatt hour. It's going to cost me this much to build my gas-fired power station or my wind farm, for example. And I can come up with an economic model. But when we shift that economic decision to being about investing in rooftop solar or battery storage or EV charging, actually the economics of those projects are really complicated because it's not just about generating and selling energy, it's about avoiding network transport costs. So about half the cost of kind of the energy that's going to that light now is the cost of transporting it from Collie to here. That's about 50% of the cost. And so you're kind of looking at not just the generation, you're looking at the transport of it, and you're looking at kind of both the opportunity to kind of create revenue by kind of selling your energy into a market, like this is kind of like you getting your feed-in tariff from Synergy, but also kind of avoiding those costs of supplying into your site. And so these projects are really kind of complicated to model. And so kind of as an enabling technology, as a software technology, our view is it's really hard to plan and optimise these projects. And so we think that's a software problem. It's not the realm of kind of consultants and spreadsheets. It's the realm of software. And so, as a team, we're building a software platform to enable that. And so, going back to this kind of challenge of, okay, we've got this existential challenge of climate change. We've got, a couple of decades now to replace all this infrastructure. There's a role for hard tech, but there's a role for soft tech or enabling tech to kind of help accelerate that transition, and that's what we do. So let me kind of show you a little bit about what it looks like. So I'm not going to log in and do a demo, but I've just got a little animated GIF here. Hopefully it gives you a bit of a sense of the software. So this is us kind of going into our platform, building a project model where we're kind of creating a site. We're adding some pricing to that site, some market pricing, some retail network pricing. In this case, we're actually kind of comparing a supermarket in London and a supermarket in Australia and saying, where is the best business case for solar and storage? And so hands up, who thinks that if you had a supermarket in Sydney that has a certain load and the equivalent supermarket in London that has the same load and installed rooftop solar on those two sites, hands up who thinks the Sydney site has the best business case? Okay, so the answer is actually the London site. And why is that? Well, pricing is really important. There's two things going on right now. So while we complain in Australia we've got really high energy prices, in fact the energy prices in the UK have gone up much faster because of the current commodity gas crisis that we've had. But in particular, the way that in the UK they price network services, so the transport of energy, is different to Australia. And the tariffs in the UK are less cost reflective. And so they kind of have, I won't go into all the nerdy details, but anyway, the structure of the network pricing means you actually get a better business case from your rooftop solar in London, even though you're getting less solar production. And so that's the kind of question, that our software is modelling. So our customers are doing things like they're developing virtual power plants, EV charging networks, residential land developments with solar and storage and community batteries, big industrial sites like big mines out in Kalgoorlie that are building kind of wind farms behind the meter. These are the kinds of projects that are being modelled in our software. So a few examples. So Synergy is one of our customers locally. So one of the things that they're doing is a bunch of kind of pilots and trials at the moment. For people who kind of follow the press, they're doing this kind of virtual power plant trial in Southern River. They've been rolling out batteries at schools. They're deploying some kind of new products to try and help these kind of decentralised energy resources, solar and batteries and EV charging, what have you, kind of be part of the solution, be part of the energy system. And so, we have helped roll out these batteries. We both do the planning and simulation, so the SimCity stuff. What would happen if we put this battery at this school and operate in a particular way? That's kind of the SimCity stuff that we do, which is kind of the planning and simulation. But we also do some performance tracking, so we'll get telemetry data off that battery. We'll see what it's actually doing, and we'll compare the actual battery with a simulated battery or a model battery, and we can use that to say, well, look, there's a performance issue. Your actual battery is cycling every day like this. When we model and optimise it, we see the battery doing something different. We're getting a better commercial outcome. So maybe go and have a look at the controls for that battery and the way it's being operated. So that's the kind of thing that we do with Synergy. Ampol is one of our customers. So Ampol is a downstream petroleum business. They do refining and trading of petroleum products, but they also have these large retail networks. They have about 2,000 service stations around Australia. They want to see a future for themselves beyond fossil fuel distribution. They want to have a future beyond the next 10 years when we're all going to be driving EVs. And so they use our software to model kind of solar and storage and EV charging at their retail sites. Another customer of ours is SNRG, which is part of Centrica. So Centrica is a big kind of British energy services business. This is our first customer in the UK. And they're developing kind of residential and industrial microgrids. So one of the things that's really nice about the UK is they have really good policy settings for decarbonisation. So if you're a residential land developer in the UK, you're required to install EV chargers on driveways. You can't have reticulated gas going into heating for new developments. And so if you're a land developer, these are more complicated projects now to develop. And so SNRG is saying, well, we've got access to project financing, we're technical experts, we will build a microgrid for you, we'll deploy community batteries and community solar, we'll operate the heat pumps and the EV chargers, and they use our software to kind of model those projects. Some other customers that we have in Australia are people like Origin Energy and AGL and Shell Energy, so kind of big retailers on the East Coast and the national electricity market. AusNet Services and Energy Queensland, who are kind of distribution network businesses. Meridian Energy and Simply Energy, who are kind of retailers in New Zealand. We've got some technology businesses, so people who kind of use our software to kind of model and create the economic case for their technology for their customers. So they're the kind of people who kind of use our software. So this is kind of an AWS talk, so I thought I'd talk a little bit about AWS and a little bit about kind of why we chose AWS, a little bit about our architecture, kind of a very big hand-wavy picture version, and then Alice will talk about some of the kind of the interesting kind of technical challenges we've been addressing recently. So if you we're about a kind of a 2-and-a-bit-year-old business. So if you go back about kind of 2 years, what was the product at that point? The product at that point was some Python code, a Jupyter notebook, a Tableau license. And we were kind of delivering that largely via a consulting engagement. So we would go to a customer who would say, you want to do a microgrid, we've written some code to model that. We would create the Jupyter notebook, we would run the simulation, we would optimise the control of the assets and the sizing of the assets, we'd publish all the simulation results to flat files, and we'd visualise them in Tableau. And that was kind of our, if you like, our MVP, where we could demonstrate that we were doing something interesting that was of value. But that's not an investable product, that's not a scalable product. And so we had to get to the point where we could kind of go to customers and give them something that could potentially be a self-service product, but also go to investors and say, hey, look, this is an investable business. We've got this pathway to this being kind of this scalable business, this software business, not a consulting business, because investors want to invest in software businesses and not consulting businesses. And so if you kind of think about if you kind of picture, we've got this Jupyter notebook, we've got this kind of Python code. One of the things we wanted to do was wrap a kind of a web application around that. So rather than someone interacting with a Jupyter notebook and kind of typing in parameters for a battery and locations for a site and what have you, we wanted them to be able to kind of point and click. But there was something kind of really powerful about this metaphor we had of a document that described the project that we could then kind of pass to our what we call our simulation engine. And so we tried to keep that kind of design decision kind of got embedded in the product very early on. So one of the things you can kind of see in the middle of this picture is we have this kind of domain-specific language. So it's a YAML file that we produce. And so when Alice and her team are kind of creating this web app, one of the things that they're generating is this kind of YAML document. And then we kind of pass that YAML document to our simulation engine. The simulation engine interprets that. It creates a whole bunch of Python data structures. It runs the simulation optimization job, and then it publishes a whole bunch of flat files. And so one of the things that's nice about that is it means that we can kind of decouple the development of the web app, this kind of scalable product that users can self-service, from the kind of the simulation optimization technology. It also means that for our kind of our data science teams and our mathematicians, they get this kind of very nice kind of easy sandbox to operate in. So they don't have to build APIs. They can just say, well, I'm going to get this kind of AWS container, I'm going to have all my files kind of served up to me, I can kind of run, and I can produce a whole bunch of flat files, and everything will kind of get taken care of for me. And also means that we can actually kind of develop those effectively two products independently. And so within the web app, one of the things you might have seen when I was kind of pointing and clicking is I was kind of adding a battery and adding a solar. But if I'm an advanced user and administrator, I can actually go in and I can edit that YAML file directly. And so there's a feature we've built in the sim engine that we haven't yet built a web interface for. It's still kind of accessible to our project model. So that design decision has been quite fundamental to the architecture of the platform. It creates some challenges for the web app, which Alice might speak to, because you've got this big heavy document that you've got to kind of pass back and forth between the browser and your server. But it has kind of allowed this decoupling. So again, we kind of reverse back 2 years or so. We had the kind of the prototype, which was the Python code. We're trying to build the web app. The job of the web app is to generate this YAML file and then also kind of interpret and help kind of users visualize the results. And so, we built an early version. I'll let Alice talk about this more kind of in Amplify, which is kind of this very kind of rapid web app prototyping platform that AWS provides. And that kind of got us to the point we had something we could kind of demonstrate to investors. We could raise our first round of funding. We could grow the team, and we could kind of invest more in actually maturing, that technology platform. I kind of talked a little bit about. I said I was going to talk about why we chose AWS, and I think one of the reasons was very much about. So the last business, the GreenSense business, we were an Azure shop. And this is kind of going back, whenever it was, 10 or 15 years. And Perth was very much a Microsoft town at the time. And so when you're trying to hire people, there were more people who kind of understood that technology stack. I guess we wanted to build a more modern platform, and we looked around the talent in Perth and in Australia. It felt like, the cool kids were developing on AWS and not Azure. And that was as much as anything one of the reasons why we kind of chose, AWS as a tech stack. There are some nice benefits for startups, which I'm sure Stefan will spruik at the end as well, which we took advantage of. I'm trying to think if there's anything else. So the other thing I want to talk about, so I talked about there kind of being two kind of products. We've kind of got the web application, we've kind of got the cognition engine, which is the trendy name, no AI. I think we discussed that over drinks, there's no AI in our product. The cognition engine, we're doing kind of simulation and numerical optimisation is what we're kind of doing there. And then I guess the emerging part of the product is the thing in the bottom right, which is about data integration. So we ingest a lot of data, so both data to support planning projects, so kind of load data for sites or market price data, and then increasingly this kind of telemetry data from assets. So I think Alice is going to predominantly talk about the web application, but if people want to ask hard questions about the data integration framework, I see Eddie lurking somewhere in the corner, and he can tell you a little bit about that. That's probably enough. So again, what I'm going to do now is I'm going to let Alice talk a little bit more about how we started and how we're kind of trying to go about maturing the product, and then very happy on Q&A to talk more about kind of the other aspects of the product, the data feeds or simulation. But Alice is going to predominantly talk about the web application.
Yeah. Thank you. You touched on the fact that there's this sort of product which we have creatively called the web app, which is just this kind of bundle of it's a React app in a S3 bucket somewhere, and it's doing one or two things. Then behind the scenes, there's some powerful Python, not AI, but some powerful Python algorithms, some Tableau magic, some feeds, APIs, some other things. And our customers just use this to interact with these powerful simulations. It's a nice, friendly face for them to work with. So when our business started, and this is before my time, I've been around for about 2.5 years now, and I've only been here for 1 year, one and a bit. And so when that web application part of the product was made, a major part of its architecture was AWS Amplify. And still to this day, Amplify is kind of a big part of our product. If you haven't worked with Amplify before, it's basically a bundle of AWS services, and it helps you to build stuff, mainly like web applications, very, very quickly. You can configure it in a bunch of different ways. Mainly, to start with, our app was using it to provision front-end infrastructure, manage deployments, manage our APIs and our data stores, manage auth through Cognito and some other things. I think it's important to note, for the most part, Amplify isn't sort of creating these services from scratch. You're using auth through Amplify, but you're actually just using Cognito. So it kind of packages up Cognito, gives you a nice console to use and to work all that out. So that's the situation what that was, and this next slide illustrates my dream for the next year or so, which is I really want to extract this product or like this framework from our product, and we'll see how I go, because every time I cut off a snake head, there's like another one sprouts. So we'll see how we're going. So what's wrong with it, Alice? Why do you hate it so much? So I think it's important to mention first that this was a framework that was chosen when the product was transitioning from like a hodgepodge of Jupyter notebooks and receipts glued together to a simple web app that customers could interact with. And for that use case, and at the time I believe we had one web developer, that was a pretty good tech stack to use, because it was something that was pretty simple and it could get the team up and running. There's one guy. So like get the product up and running. You could show it to investors. You could get customers with it, and we did. And for that use case, I think it's quite strong. But the issue is, as the complexity of your product and the size of your team grows, you might find that you outgrow this kind of managed service quite quickly. So there are a few, as I mentioned, Amplify is it's a basket of different AWS services. So there are a few different parts of it that specifically we are outgrowing. I'm going to talk about two of them, but there are some other areas which it's not quite the right fit. We're probably going to move on to something else in the future. So initially, Amplify was managing both our APIs and our sort of CRUD data store. So Amplify will provision you a sort of an AppSync instance, which is a sort of managed GraphQL instance. Amplify can also provide you with a schema language, and I've just given a little example of it there. So you can imagine using this kind of schema language to establish a really simple CRUD data store. So you're like, okay, I'm going to make my to-do app, and I'm going to have my posts and my to-do items and my users and my other very simple models. And you just write your lovely little schema language, and you press go, and Amplify magically generates beautiful, GraphQL instance that can honor those requests, and also generate some DynamoDB data stores for you to use. This is great when you're building your little to-do app and you're maybe like a simpler application. We have run into quite a few problems with this system, and I feel like we've sort of customized it to the limit that is sort of sensible to do, and it's time to kind of move on to something a bit more appropriate for our needs. And some of the specific issues we've been having with it is that if you want to use AppSync and retrieve data from custom sources, which is something that we do quite a lot, we're not just putting stuff into DynamoDB and taking it out. We are pulling things from, a giant, Parquet file of data points, or, we have these huge... That's fine. These are just Fabian's glasses. I'll put them back there. We're pulling data from all these different sources, or like third-party APIs, things like that. And for that use case with AppSync, you can either write custom VTL, which is a very heavy language, or you can create a custom Lambda per query or mutation that you want to do. I feel that we were falling into all these anti-patterns. I felt like our supposed GraphQL server was actually looking a lot like a REST API. It was very slow to deploy. It was really hard to share logic between all these different services. We were running into all kinds of problems like that. There are a few other things about the way that it worked out of the box that I felt was encouraging anti-patterns as well. Like, it very helpfully generates a bunch of query strings and mutations for you, and I feel like it's natural for people then to go, oh, here's this nice auto-generated GraphQL query. I'm just going to go and use that. But this auto-generated GraphQL query might include all the properties of your very, very complex object. And in most cases, maybe you just need 3 of those, and you don't need to pull back this massive object from the server. Also, out of the box, the way that Amplify was configuring the combination of AppSync and DynamoDB, I'm not sure if this is something that we could possibly configure our way out of to make it better, but it made certain things impossible, and I felt like it didn't really use the strengths of DynamoDB. So in my little example where I have a post, object, and then maybe I have another object which is my author of the post, that would create 2 separate DynamoDB tables. I don't know how much people in the audience have worked with DynamoDB, but in my mind, that's almost like a SQL way of thinking about it, where you create all these different tables and then, you can magically link them together later. And in my experience with DynamoDB, it doesn't really work like that. You can't really kind of cross-query tables with that same efficiency. And so when we went to do certain queries, we're kind of backed into a corner. It was really inefficient to do them. And even though our data set is not huge, we have a few hundred customers, we have a few hundred projects, these queries like grinding to a halt. They're really, really slow and unperformant. Another part of the console Amplify product that we felt that we had outgrown was there's this thing called the Amplify console. It can manage your deployments and provision front-end infrastructure for you. And an issue we ran into, I feel like we've mostly transitioned completely away from this, was that the way that it provisioned front-end infrastructure, so the exact way that it span up a CloudFront instance for us and the way the S3 bucket was configured, we had some weird business requirements around like some caching things, and it just wasn't quite right. Tied into that was the fact that we have some other like CI/CD actions that we wanted to tie into things that were happening with the Amplify console, and there wasn't really a way to get a nice, send a message to the Amplify console, and then when it's done, send a message back and trigger some other tests or actions. And so we ended up pulling the whole thing out and putting it instead in GitHub Actions, and all those custom front-end resources, we just ended up using CDK, so we could provision them in kind of the way that we wanted to. So basically, out of the box, we wanted a lot more configuration than what was immediately apparent to us, and it seemed a lot easier to go with a more like customizable solution. So the solution to both these problems and other issues we've been having with more like managed services is kind of swapping them out bit by bit for more customizable, like primitive AWS products. That's kind of easy to say, but the process of actually doing this is quite difficult. So first of all, I think, it's nice to draw a little diagram on the board and be like, this is what we were and this is what we're going to be. And actually going through that process and doing that is much more difficult than you might think, especially because our product is a live product. We have customers and they do pay us money for using the product. And if the product suddenly stops working, they will rightfully be a little bit annoyed. And, we also can't like hang up a closed sign for like 2 months while we go and change all this stuff. Or maybe we could get one of those GIFs from like the 90s where it's like work in progress. I don't know. So basically we had to think about some patterns that would allow for incremental change from one kind of infrastructure to another. So what we did for the AppSync change, like before we were with a sort of AppSync model for our APIs, and this is kind of how they were working. And as I mentioned, we had to build all these custom resolvers to create our complex business model objects. And, there are a lot of these custom resolvers, and they're reaching out to third-party APIs and S3 documents and random EC2 instances and other things. So the first step to move away from this was pretty simple, which was we just plopped a Apollo Gateway in front of our AppSync instance. For those of you who don't know, Apollo Gateway is, if you have a GraphQL graph, you can use Apollo, or like multiple GraphQL graphs, you can use Apollo Gateway to kind of combine those into a supergraph. So you send requests to your gateway, it looks at its huge compiled GraphQL schema and says, I know that this model type, I need to send it off to this specific subgraph or this one or this one. Now to start with, it seems a bit weird because we put this gateway here and there's only one subgraph, which is still AppSync. So it's just getting requests, it looks at its big list and it's like, okay, cool, I'm sending that off to AppSync. But the reason we did this is, as I mentioned, it's a live product. We have customers currently and we can't really make these big dramatic changes all at once. And so the end idea with this change is that then we could move on to something like this, where incrementally things go to the Apollo Gateway and we're slowly pulling responsibilities away to custom Apollo servers. And those Apollo servers are responsible for all our weird business logic as time goes on. We currently have one, but I'm imagining we're going to add a few more for more specific like subgraph things to deal with specific kinds of business logic. At the same time, we can still use AppSync, and AppSync is probably still going to be used for quite some time for those simple, those kind of to-do models where it's like, hey, we just have this little bit of data, we put it in DynamoDB and then we take it out again. It's not very interesting, but that's the kind of cornerstone of a lot of applications. I also have an idea that eventually you won't directly be able to query AppSync from our gateway. Like AppSync might be a tool that we use on our subgraphs to store, application data, but that's never surfaced directly to the client, so they actually can't go and see it. And that might just be something that we use behind the scenes to power stuff. As I mentioned as well, so previously we were using the Amplify console to manage some of our deployments. It was a bit mysterious to me what was actually happening in here, because one of the issues I found with the console, it was really hard to see what resources it was actually provisioning. I believe some of the resources it provisioned, it kind of hid the resource from us, even though we had like admin powers. I was like, where is this like bucket that they've actually provisioned for us that's hosting our front end stuff? I can't find it anywhere. And so I think it would be like, we could have actually, if we'd been able to configure it a bit more, we might have kept some of those resources around. But because it was, we didn't want to throw the baby out with the bathwater, but we kind of had to, because they were, tied together. And so that's just allowed us to transition over to basically all this infrastructure that was being managed by the console. We now manage through CDK, which is just, I don't know, if you've not used CDK, it's similar to, serverless or Pulumi or, infrastructure as code stuff. Lets us write all our infrastructure out in nice little TypeScript classes, and I find it quite readable. And these actions are just triggered by things on GitHub, so pull requests being closed or a branch being merged, something like that. The nice thing about moving all that over to our GitHub Actions pipeline is that's kind of tied in with a lot of our testing infrastructure. So if certain tests fail, the deployment doesn't go forward, or if one action in the deployment fails, the other actions are aware of that and can, have a fallback strategy, or, post an alert to Slack, or do any of the things that they were going to do. So the overall takeaways that I wanted to sort of mention about basically being in a startup and working with AWS is, I think it's completely fine to start with these sort of managed services like Amplify, or I'm sure there are other examples of them, when the capacity or capability of your tech team is like quite limited. So you're trying to get a product off the ground really quickly. Your developers have quite a lot to do already, and maybe you are a startup, you don't necessarily have a lot of IP ready to go. I know some larger organizations might have a pattern already of how they might like to develop their apps that they could use, but as a startup, you probably don't have that. And then once you've just picked something to get your product off the ground, it's fine to then incrementally move away from those products as you outgrow them, and using patterns that lets you take step by step to move away from that. And I think the final takeaway is, if things from your initial managed service system work fine, then keep using them. There are a few products in Amplify that I think we're probably just going to keep using, like their way of managing like the Cognito stuff. I'm like, well, it's not caused any problems. Let's just leave it alone for the time being. We've got plenty of other stuff to work on. So yeah, that's my summary. I'm happy to answer any questions about this area, or if you're going to come up to me afterwards and be like, well, actually, Amplify can do all those things, I'll fight you. But oh yeah, we got to do the socials and the photos and stuff.
No. We're going to do questions.
Oh, questions.
So happy to field questions about energy system transition, climate change stuff, about the broader architecture, or about the web app stuff. So feel free to fire away.
You could just repeat the questions. So
Sure.
Oh yeah. Good thing.
How you guys storing everything in one single account, so that all clients share the environment, or create?
So currently we.
Do you want to repeat the question?
Oh yeah, sorry. Yeah, the question was, do we just have one AWS account? Currently, I think we have 3 sort of AWS accounts. The first one is just our sort of like admin overhead account where we keep all our users, our developers registered. We have a dev account where we keep all our dev resources, and we play around it, and we do lots of random things in there. We also have our production instance, which we do try and keep a bit more locked down. So only the developers have access to it, and 1 or 2 customer-facing people have read-only access to it. I think we have discussed the fact that in future we might get a customer who says, I don't want my precious data and all my stuff sitting next to some other random person. Yeah, I want to have it over here in my own, completely different account, which or they might want it in a different zone, that kind of thing. So we'll burn that bridge when we come to it, I think.
If they pay us enough money.
Yeah, if they pay us enough money to establish it. I think the thing is we've done this process. So initially everything was in the same account. And then I think about a year ago, we started the process of pulling everything out and being a bit more, mature about it. So we've done that process once. We can do it again. So if needed.
Christian?
Where's the growth in demand going to come from in this system? Numbers of web users, the amount of processing in the back end, more data ingestion. Where's your next scalability challenge?
Well, I guess one of the things that we focus on in terms of measuring the success of the business is the number of simulations that are being run. So, as an internal user, when we log in, the first thing we see is this plot of how many simulations are being run, and those simulations can either be planning simulations, the upfront SimCity stuff, or the kind of what we call the tracking simulations, so kind of modelling a kind of deployed asset. So I think there's a few kind of scalability or growth challenges. So I think there's an ongoing piece of work around the web app, which kind of Alice is leading. We've got, right now, the way we kind of run simulations is we do kind of vertical scaling. So we kind of assess kind of how many different kind of variations there are in a simulation, and we'll provision a larger or smaller container as a result. But we've done some prototyping of kind of a horizontal scaling model, and that's something that we'll probably implement relatively soon. It seems to be more cost efficient to kind of have lots of small machines than one big machine, and the problem we have lends itself to that kind of scaling. And I guess the bigger kind of emerging challenge is around kind of data feeds and data integration, and we see that as being kind of an area where we kind of again had a prototype solution for the last kind of 6 months, and we're kind of in the process of kind of starting again with the architecture for that. At the back.
I was just going to ask, do you use spot instances at all if you're using lots of little...
So the question was, do we use spot instances? So no, we don't. So what we do at the moment is we schedule or kind of orchestrate the simulation jobs in a couple of different ways, but one of the main ways we do it is with AWS Batch.
I'm just curious about the level of detail of these simulations. So I imagine you don't do like the pure physics simulations?
Yeah,
sorry, just to kind of, where I'm going with that is, especially given the space you're in, you're going to be dealing with lots of new emerging technology over the next few years. So when like battery types come out and so on and so forth, you have to encode that in your simulation somehow. So I'm just wondering about how do you model that kind of...
Yep, that's a good question. So the question was kind of, what's the level of detail in our simulations, and are we doing kind of physics accurate simulations? So there's this whole kind of category of product that's kind of called power flow modelling. And so if you're an engineer and you perhaps work for Western Power and you're assessing someone who wants to connect a wind farm to the network, you're doing power flow modelling, and that's the physics accurate modelling. So we don't do that. Our philosophy is we want to have enough technical fidelity in the modelling of the energy flows that we get the commercials right. But our main result we're producing is the commercial result. And so the way we kind of think about the simulation problem is there's a few different aspects to it. So one aspect to it is kind of modelling the loads. So what's the underlying load at the site? Like how much energy is this building using? What's the behaviour of a battery storage system or an EV charging system or a wind turbine or a genset or a battery system? We have these parametric models of those assets that we've developed internally, so we can kind of say, well, it's a 200 kilowatt wind turbine that's this tall and it's here on the coast, and we get wind data in and we simulate it. We're not trying to replicate or replace the specialised wind turbine modelling software or the specialised battery system modelling software. We're trying to provide this kind of integrated platform that brings all that together. So we have these parametric models for all the different DER assets. And then the key thing that we're doing is, traditionally when you thought about, so let's say solar as an example, you didn't think about control. So your solar system, it was just kind of modelling, it was just kind of trigonometry. It's like, where's the sun, angle of the panels, what's the energy conversion efficiency? But for all the assets we're modelling, we have to think about control. We have to think about this kind of asset dynamically responding to price signals and market conditions and what have you. And even for solar, we will model control of solar and turning down solar into negative prices. So a big part of the problem we're solving is simulating some kind of intelligent control system that's co-optimising all of these assets in response to a whole bunch of different kind of complicated price signals. So we put probably as much effort into that, if not more effort into that, as we do into the energy flow modelling. And then the third part of the problem is really the commercial assessment. So, you've got this site, and we might model lots of different permutations of projects at this site with different sized batteries and PV systems and different commercial models and direct wholesale market exposure or not. And each of those will kind of generate a different kind of shape to the load, and we'll kind of price those against a whole bunch of different price signals. So we're kind of doing the physical energy flow modelling with enough technical fidelity that it's accurate. we're doing the simulation of the control system, and then we're kind of doing the commercial calculation so we can produce these kind of cash flow models for all of our project stakeholders. And we'll do that at kind of a granularity that depends on the market jurisdiction. So in WA, that would be kind of half-hour interval level simulations. In the East Coast, that's kind of 5-minute interval level simulations. And that might be over like a 15 or 20-year asset life, and that might be with a few thousand different project variations. So there's kind of lots and lots of simulation permutations that are being run. So question over there.
So what decision would using the software feed into? So in terms of like a major capital project, if you're going to look at 5 gigawatts of solar, wind and a battery to suit, and then you were going to take that decision forward perhaps from concept to pre-phase to FID, would it be enough to inform that FID decision in terms of that detail? No,
it's a great question. Depends on the customer and the scale of the project. So for distributed or small projects, so we're talking about like rooftop solar on a shopping centre, something like that, it would go to FID through our software. But if you're doing something like a big battery, utility scale battery, like the battery that Synergy's building at Kwinana, or a big wind farm, then the part that we would do in our software is the opportunity assessment, the pre-fees. But when you're trying to do that kind of bankable revenue study, people are still kind of engaging consultants who will kind of sign off on the revenue forecast that you can then take to an infrastructure investor or an investment committee.
Do you get any feedback from people that are kind of like decision analysts, if you work with them, that we don't like black boxes? So when you think about architecting something that's a lot more robust than an Excel spreadsheet with weird VBA macros and really clunky features, and you want to go, okay, well, we should do something more scalable. A lot of the critique I get on that is we don't like a black box. We want to be able to audit every single calculation should we need to. And it might sound kind of insane, but people do have...
Oh no, that's 100%. No, it's a good question. So the question was, do people who are trying to make these investment decisions, are they comfortable with there being kind of a black box that said, answer is project option 753? And again, the answer is kind of depends on the customer. I guess one of the things that we don't do is we're not doing anything super clever. Like we're not AI. There's no neural networks. There's nothing that's kind of black box in that sense. Like the optimization that we're running is a numerical optimization, and it's very explainable. We do still have customers that want to understand, why was the battery charging or discharging in a given interval, and so they can download and inspect kind of these interval level profiles to see that the battery is doing something in a given 5-minute interval. The thing we're just about to make available is a kind of a custom report where people can see in that interval what were all the price signals that the optimizer was kind of responding to, and that should be enough to kind of reverse engineer the kind of the decision logic. That hasn't come up that often, but it has come up. Lots of questions. So over here.
Alice, you said that when you guys first started with Amplify, you're using multiple tables with DynamoDB.
Yep.
And you said that that this is not the way it was designed to be used. Have you guys managed to migrate to a more single table design, or are you planning on bringing that in?
I think that would be the ideal set. Like if we continued using DynamoDB as a data store, that would probably be the ideal way to do it. I know, so I've heard different opinions about, so some people prefer to do the single table store thing, and other people, I've heard also that you can have a, what's it called? It used to be called Elasticsearch, now it's called OpenSearch, I think, that you kind of put over the top of everything to like link it all together nicely. Currently we don't do any of that, so I feel like I don't know what would be the ideal solution to move on to. It's just one of these things where I'm like, clearly what we're doing at the moment is not quite right, and I feel like we don't currently have the tools to use to move that infrastructure into a way that it can be optimized more. So yeah, in future it would be nice to do it better. What are we going to do? I don't know. I guess we'll figure it out.
This is not quite the question you're asking, but I'll just kind of make another comment, which is one of the things I think is interesting about our product is that a big part of our data structure is this kind of domain-specific language, or these YAML documents. So not everything that kind of sits in our software that we're kind of representing is being represented in database tables, and there's both the kind of advantages and disadvantages of that approach, but it does mean that we can kind of move very quickly and evolve in the simulation engine and involve the kinds of objects that we can kind of simulate and optimize. And so that doesn't kind of get serialized into a database.
We also have quite a lot of data that is sort of, it's like Parquet files of like every 15 seconds, here's the energy output of something, and then it's sort of like that every 5 minutes for a year or something like that. So yeah, DynamoDB is just one part of where we're storing our data. Yeah, if you have any suggestions about where we should put it next, love to hear them afterwards.
You guys are finding distribution loss factors, transmission loss factors, weather information, and then power profiles for generation of those specific bits of equipment then to then do that simulation.
Yeah, so they're kind of, so the question was, do we consider kind of loss factors and weather conditions?
I think in your preview we had a distribution and loss factor little option to put in your form.
Yeah.
So.
So the answer is yes, and I guess this is kind of part of our philosophy of having enough technical fidelity to get the commercials right, and those kinds of issues, they're very significant for the commercial outcome. So for people who didn't kind of follow that, so one of the things that we might think about is one of our customers right now is modelling a project, an interesting project. So it's out in Mullawa. So this is a kind of this wheat belt town, kind of east of Geraldton, and the energy from Mullawa comes from all the power stations in the Southwest Interconnect system. But there are very high losses for that energy to get from, like, let's say, kind of Collie up to Mullawa. And those loss factors can be up to 20% or 25%. So, you generate a unit of energy at the coal-fired power station in Collie. By the time it gets to the town of Mullawa, you've lost a big percentage of that energy. And so if you're trying to consider the opportunity to build a solar farm in Mullawa or a wind farm in Mullawa or a battery system in Mullawa, it doesn't have to be as cost-effective as the power coming out from Collie, because that power from Collie is kind of taxed by this kind of loss factor. So that's kind of an example of one of the considerations in the software.
So how granular do you get your geospatial information then on that network side of things?
So yeah, so we don't do so the question was kind of how granular is the kind of the geospatial information. So it's relatively granular in terms of the climate data, so kind of irradiance data and wind data that we use for modelling the output from variable renewable systems like wind and solar systems. In relation to, I guess, the power flow side, I guess the way that we think about it is we're not actually trying to get the exact number, which is the exact number of the losses between, let's say, Collie and Mullawa, because the exact number actually isn't meaningful to the commercial calculation. What's meaningful to the calculation is the deemed number, the number that Western Power ascribes to that network connection. So the number that we use is that number that's ascribed by Western Power, because that's the number that derives the commercial outcome, the effect of the cost of energy or the opportunity cost to move to something else. So we actually had an interesting kind of catch up with another team in Canberra today who does build power flow modelling tools for networks, and we talked about some interesting opportunities for us to collaborate. So they're very much on that very physics accurate side of this, whereas we're very much on the commercial side.
What's your business model like? Do all of your clients that have similar needs and requirements, or is it more specific? So do you provide generic solution? Or?
Yeah, so the question was kind of what's our business model? So our business model is very simple. So we're a SaaS business, and so customers would generally pay kind of an annual subscription fee for the use of the software, and we set some limits on that in terms of the kind of the number of simulations they can run or the number of users. We tend not to provide kind of modelling services or consulting services. We'll actually do lots of hand holding because these are complicated projects to try and get our users up to speed. But our business model is a software business model and kind of selling the software as a service.
So you just do predictions, or you also get feedback, like how accurate it was?
So the question was, do we do predictions? So we don't do predictions in the machine learning sense. So we don't have forecasting algorithms in our software, but we do predictions in the sense of when you think about modelling, let's say a simple example of a solar farm that's going to produce energy over 25 years. We're producing a prediction which is what's the economic value of that solar farm over that 25-year period. And those inputs will include the output from the solar farm. It will include a view on the future energy market prices. And so in that sense, we're creating a prediction. We're creating a prediction of what the economic value will be, but we're not doing kind of a machine learning style kind of forecasting activity.
So how do we get feedback? Like, was it accurate enough?
Yes, the question was kind of how do we get feedback? How do we know if we're running these kind of SimCity models, how do we know if they're right? So I guess there's two parts to the answers to the question. So one is that I guess we have subject matter experts who kind of review and review the models that we've created, and we've had kind of real asset data that we use to kind of calibrate those models. That's part of the answer. But the other part of the answer is kind of it's a product answer. So we have two products. We price them separately. The first product is the planning product, it's the SimCity product. The second product is the performance monitoring product. The performance monitoring product, we do that for two reasons. So one reason is it's helping us solve the problem for our customer. The problem for the customer we're solving is confidence in an investment decision. And so part of that confidence comes from us kind of tracking and assuring the revenue or the value from that project. But the other reason we do that tracking product is it gives us access to asset telemetry data and market price data that we can use to kind of calibrate our models and keep ourselves honest in terms of that upfront modelling. I think so.
Might just have to make this one the last question.
Sure.
Though. I think we could be here for quite a while.
With your equations and your numerical optimizations, how do you go optimizing your constants and your equations, and how do you validate that in your model? I think you might have answered it a little bit already.
Yes, I mean, I think so. One of the things that so we're going to stray slightly out of my area of expertise here, but I'll have a crack. So one of the things we're trying to do is we're trying to keep all the optimization linear, but in fact the problem we're solving isn't entirely linear. And so part of the magic in the software is taking these kind of non-linear problems and coming up with heuristics to turn them into linear problems. And so that's part of what we're doing. And one of the reasons we do that is, linear optimization is much more likely to converge on a solution. It runs much faster, and when we're running lots of permutations, then we're more likely to get a good answer for our customers. But we are increasingly running into problems where we can't kind of coerce it into being a kind of a linear optimization problem, and it's something we might have to revisit in the future. Thank you very much.
Thank you.
Are focused on a problem and know what you're doing well and what you're not doing well, and just keep chipping away at it. It was a great presentation. Thank you. Stefan Knight from AWS is going to talk to us about how they can help startups.
Cool. No slides. Just going to talk. I really appreciate Alice and Fabian coming out. I asked them if they would come speak at this user group meeting. And I've known Fabian for a little while, and he came into our startup program, which I'll talk about, Activate, through, I'm not sure how you first came in. You might have come, did you come in through Climate Salad originally?
StartMate.
StartMate, okay, cool. So we'll talk about that. So we have different partners. In fact, we're in the space of one of those. Activate is what the program is called, Partner. SpaceCube, Flux. There are different ways that you can kind of pop up on the radar and work with AWS, but I really appreciate them coming. What I love about their story is, hey, they're here in Perth, and they have customers now in the UK, they'll have customers in the US, they'll have customers in Europe. I've been coming to Perth now for about 6 years, doing work in the startup ecosystem. I used to run Telstra's Startup Accelerator, Murudi in Sydney, and we had a joint program here, the Plus8 program with the SpaceCube folks. So I've been coming here over the years, and I'm really impressed, what I see. And in my role at AWS, I look after startups. I look after AgWorld and AppBot and other startups here, startups in Brisbane, startups in Adelaide. So I just wanted to take a couple of minutes to talk about the startup program. Many of you are working in bigger companies, but you might get an idea one day, like I might like to take the first step in becoming a startup, or you might want to join a startup. And it'd be useful to be aware of what AWS does to support startups along the way. And I'll tie it back to Gridcognition and use it as a case study, really, of how we've worked together and to try to support them, to get where they are going, and hopefully continue to support them long into the future as they successfully, transition and scale, the business. So we have this startup program. It's called Activate. Most of the people on the team that I work on are all startup people. So I have a startup background from believe it or not, the early 90s forward. Actually pre-internet. I've done programming, I've done product management, product marketing, and more lately business development, sales, those kinds of things. I was at a startup called Gorilla Stack, which was exited 3 years ago, and AWS said, hey, we're going to build this startup team with people with startup background that have some credibility with startups. So I said, great, that sounds like fun, and I came on board. And so in this Activate program, there are people like me that kind of look after making sure that the companies are getting the best out of AWS, because there's a lot of programs for startups. We've got credit programs, we've got support programs, we've got co-selling programs, all kinds of stuff. If you're a startup running on another cloud platform, we've got migration programs to help you come over. And so I'm your human API into all things AWS. I try to figure all this stuff out. So we have energy people in the States that look after energy globally. So when I see a story like Fabian's, I want to get that on their radar. I want them to know about it so they can hopefully make business connections and introductions and things like that. So I'm the commercial guy, the human API. On the team as well, we have solution architects. So I'll use the example of Amplify. So the CTO for Gridcognition, Sam, is in Sydney. I remember the first conversation I had with Sam. I love like direct conversations where there's no sugarcoating it at all. He's like, this Amplify stuff sucks. Lots of questions, lots of issues. Alice and I want to talk to somebody who knows something about it. So our day-to-day solution architect, Ben Duncan, who I work with, really good guy, but he doesn't know Amplify cold, he doesn't know AppSync cold. So what do? We reach back into the organization, find somebody on the product team, and got some amazing people on these calls, and we really did flesh out where the absolute certainty of issues was, or whether it was a config thing or a use thing or whatnot. And we come out and say, you are maturing beyond the need to use these managed. I mean, Alice, you said it perfectly in your slides. I don't need to repeat it. It's like, yeah, that actually makes sense. You graduated. Yeah, exactly. It's not matured, graduated, or these are built for these use cases. This is built for these use cases, and you've gone beyond those use cases. So by all means, let's come up with a new solution. And that's how we treat all the startups that we work with in the program, and try to understand your business, try to understand your business problems, and work through those. And we have some programs where we work with our consulting partners. There's Journey One is in the room, Mechanical Rock is in the room, other consulting partners where we'll tip in some funding to help achieve like a modernization outcome, to help you get into containers or serverless or things like that. So if I've done my job well, I've kind of deposited in your brain that there is actually a team of real people with startup experience at AWS that looks after startup companies. Whether you're in a startup now or you join one in the future or you start your own company, there are different entry points, and we're here to help, most definitely. You can find us via the local AWS team, or you can ping the folks at Flux or SpaceCube. They know how to get in touch with us, and or you can come up to me today and give me a card, and I'll be happy to give me your details, do a LinkedIn thing. Be happy to follow up with you. But I'm your main AWS startup person for Perth. I don't live here, unfortunately. I live in Brisbane. Sorry, I'm one of those seagulls that flies in. Sorry about that. But look forward to coming back. The last time I was in Perth, I was in this very room for a startup pitch night. So I look forward to coming back and getting to know people better and helping them as we move on. And lastly, I want to thank Alice and Fabian again. I want to thank Jen for suggesting it and Christian for having us along. And I hope you got a lot out of it. I certainly did. I know even more about the Gridcognition business and story, so I appreciate it. And I appreciate you coming and doing it and kind of helping out the community. It was awesome. We were worried it wasn't going to be technical enough. Alice, you killed it. You nailed it. Thanks very much.